Hi everyone. In this video, I wanted to go through the backend services of my genealogy project and demonstrate how I put together this family tree. So this project is still very much a work in progress. It's very rough and may not be that intuitive at the moment, but I have a few ideas and I'm working towards sort of getting it to work properly. To begin with, My Genealogy Project is a context-sensitive family tree that time capsules what family members think of each other. Think of it as a collection of memories shared about a person by those who know them at a specific point in their lives. So eventually you'll be able to click on a person and see a list of pictures, see who has talked about them and what they have said, but it's not there yet. All right, so the way I thought I would demonstrate this is with a collage of myself. So just imagine that this is a family portrait and these are the different people that make up that family. So what we want to do is we first want to extract these mugshots and use it to create a family tree like this. So where we have the parents above and then the children's below them. So in this particular family tree, the way I've set it up is that A and B are married to each other, C and D are married to each other, and then C and E get married to each other. F and G are married to each other, and then H and I are married to each other. And for the children or the families, we have A, B, and F are a family, where A and B are the parents. And likewise, G is a child of C and E. And then we have H, which is a child of F and G. So we want to construct a family tree that has all of these relationships encoded within it. And then the names of these family members are just different letters of the alphabet, so A through to I. So the way we do this, if we head to the actual website, so the backend is actually a Flask application. It's quite simple. It just runs on my local machine. So where we're going first is the Identify Mugshots page. We'll add in the image or the collage. So this again, even though they are pictures of me, we just want to assume for the sake of this example that it's a family portrait and that there are different people within that family portrait. The year when this picture was taken, so in this particular case, we're going to set it to 2025. This information is only relevant when you have multiple pictures of the same person. So if one particular family member has multiple pictures associated with them, then you want to sort of provide this year so that we know what order we should display the pictures in. So we want to try provide or we want to try to display the most recent picture first. So we're going to go ahead and submit this to the server, and in the backend we're using the Python face recognition library to identify the mugshots in that image and provide us with the bounding boxes for each person that it has identified. So eventually it'll go through and it will complete and it will give us that information. So there we go. It's now completed and the server returned. It's basically telling us that it was able to identify 4 pictures of 4 people in the image that we provided, which is correct. And it's listing out the bounding boxes that it identified. So I've taken this information and using Canva, I can print out that image to my canvas. With Canva, Canva allows you to add different shapes to a canvas. And all I've done is I've added in these red squares that indicate the bounding boxes that our Python face recognition library identified. And as you can see, it's done a really good job. And the green squares are just the same squares, but just 1.5 times bigger and centered around the red square. So that that area or the green box indicates the area that will be cropped out. And because I'm using Convo, I can move these shapes around and resize them and do things like that. So they provide a transformer functionality to be able to sort of do that. One interesting thing I found while working with Convo, so I come from a Java Swing background, and for me, we work with affine transformation. So we draw our shapes directly to a canvas, and then we apply affine transformations or a matrix to manage the scaling and rotation or translation of all of those objects on that drawn plane. But Converse seems to be a bit different, or maybe I'm just not sure how to work with it properly. But particularly with these transformers, so the thing that allows me to resize the actual shapes, it seems that the resizing happens or is applied to the scale of the objects or of the shapes within it, and not actually applied to the dimensions or the actual height and width of this object. So I'm not sure why they have done it that way. Normally we would do it, normally we would just adjust the height and width of the shape, and then the scaling would happen, um, would be applied when you're zooming in or zooming out or changing some other aspect of it. So I'm not sure why they have done it this way. Hopefully I'll discover it as I'm working with it. But that was something interesting that I identified. I've also added in other functionality. So you can not just move these and scale them down, or resize them to fit the area that you exactly want to crop. But you can also double click in to add your own extraction areas. This is not working properly because it's introducing too many. But what you can do is I've also added in the ability to select them and then delete the ones that you don't want. So that bit is working. And it's kind of smart as well, where if you move this outside of the range of the image, then it's not going to try to extract anything. It's going to assume that this bounding box is to be deleted. So let's just make sure that's all in there. And then we can verify this. Just if you look down on the page, we can see all of the bounding boxes that it's going to extract. Nothing is in the negative. The original name of the image that we provided, and also the year the image, or the estimated year that we think this image was taken. So we're going to submit this information again to the backend, and this time it's actually going to provide us with a set of files that will help us work with the mugshots. All right, so now that we have downloaded that information, we just need to tie everything together. So if I go into my raw family data folder, and now this is the zip file that we just downloaded. So let's just extract it here. So it's going to have my original image. It's going to have my mugshots. They're sort of numbered. They will each have an identifier associated with them. And in this mugshots JSON file, we'll just be able to see the identifier and then the bounding box associated with that in terms of the original image that we cropped it out of. And this will come in handy later on when I eventually add in the functionality to point out different people in an image when you're looking at it in the front end. So at the moment it has no relevance, but eventually it will. So the next step, actually, once we have this data, once we have the mugshots particularly, is to work on our data files. So this is quite a manual process at the moment. So I've broken it down into 3 files. We have the file that maps our immediate families. So we can list out the parents and then all of the children that are associated with those parents. The marriages, so this is for each person, we can tell who they're married to. and when they were wed, and if they were divorced. Although divorce doesn't feature at the moment. Or I haven't really worked out an idea of what to do with the divorced information, and it's not something that's sort of readily available either. So that might be removed later on. And then we have the raw family tree data. So this is the main file. This is where we enter in all of the information for each family member, and then we use the other files to basically tie them all together. So this is what these files look like. And what we're going to do now is go back to our family tree, and we're going to try replicate this information in our raw JSON data. And we're going to start with the mugshots, or actually we will just start with entering information for each of these family members. So we'll start with A, because there's no mugshot associated with them. It's fine. We don't need to worry about the born, died, mugshot information or anything like that. And we'll just keep going like that. And we will keep going on and doing this for each family member, and then we would also add in any information that we have of that person. So next we'll put in F. So F is unique because they have a mugshot. So if we go back to our mugshots folder, and F is this guy here. So we can just copy the file name and just put it into our mugshots list over here. So next we have G. So all we've done is we've entered in each name of the person. We don't know the born, died, and all of that information, so we've just left it blank. And we've also tied in the mugshot images for each of the family members that have a mugshot associated with them. So the next item is marriages. So if we head to our marriages.json file, in the marriages file, we'll just list out each of the people that are married. So we have A married to B. We have C married to D. And we have H married to I. So those are our marriages. And then the next piece of information that we need is our immediate families. So if you look at parents and children, we know that A and B are parents to F. And we know that C and E are parents to G. And finally, F and G are parents to H. So the identifiers have to match the identifiers that we have provided in the raw family tree JSON file. But once we have that information, we are basically done. So we have mapped immediate families, marriages, and raw information. Okay, so once we are done here, we will head back to our website, and we just want to head back to the home page. And we want to generate a consolidated family tree. So over here, we will submit the raw family tree JSON, the marriages file, and our parents children mapping. And once we submit this, we will get back a family tree.json file. So this file will contain a lot of duplicate information. So let's just have a quick look at it. This is the one here. So it's not the file that we normally work with, just because it allows you to make too many mistakes, because we basically identify, for each marriage, for instance, we know that A married B. So when you look at A, you're going to see a married property for B. And likewise, when you then go and look out B, you're going to see a married option for A. So there's a lot of duplicate information in there, and you're going to make mistakes with the dates and years and things like that. And to sort of eliminate that, you're working with three high-level files that will eventually get put into one file. So once we have this file, we still don't know where exactly these people are going to sit in our family tree. So if you look at the family tree over here, we know that we want the people to sit in this sort of configuration where we have the parents on top and then the children below them, and where we can see marriages next to each other and so on. So we still don't have that information in this file, and that's where the next step comes in. So what we can do is we can head back to the website, and we'll head back to our landing page, and over here we're going to convert the family tree into a display file, or into a set of display files. So we're just going to add in our family tree JSON file, and we're going to submit that, and it's going to output a zip. So we're just going to take that zip and just save it. So if we extract it, here we go. So this information is what we provide to the front end in order to display that nice tree. So the retry list should be empty. So yeah, it just tells us what family members it wasn't able to fit in our family tree. The display data is actually all of the family member information that we have, plus the location of where it should fit in the tree. So these will be integers that will eventually work out the actual positions for, and then build the boxes around and paint them properly. But at the moment, think of it as a grid, and it's just placing family members in a grid. Originally I was using Cytoscape to do this, but I couldn't wrap my head around the documentation, and I wanted to do more custom things to it, and I ended up going with Canva, and I preferred to work with different shapes and adding like that coming from a JavaScript background, that was more familiar to me, especially with what I used to do. So it was easier to go from Java Swing to Convert than it was to go from Java Swing to Cytoscape, which there was more involved in trying to understand how to manipulate the display of things. And finally, the connection data just tells us who these people, or what the relationships are between these different family members. So I want to sort of go through and explain how the layout works. So it's a custom process that I've developed. Family member can be provided in that family tree.json file in any order. So the first family member that we encounter might be G over here. And once we encounter that family member, we will just place it in a grid. So at the moment, there are no coordinates associated with this person. If we assume that this is a node in a graph, then assume that it has an up, it has a bottom, it has a left and a right. So we can connect this node to other nodes in our grid. So the idea is that all the parents will be connected above, the children will be connected below, and the partners will be connected on the right. So when we receive a family member, so in this case G, the first thing we will do is get the parents of G. The second thing we will look at, or the second priority, would be the children, and then the last priority will be the partners. So we'll first get G, and then we will get the parents of G, and the parents of G will be placed directly above G in the grid. C is a parent of G, and so C has been placed above G. Now, what happens to E? So E is also a parent of G. So when we get E, we have to place E above G. And we've already got C occupying the space. So what happens is when we try to place the parent, what it's going to do is look at the next available slot to the right. So if there's already a node over here, then it's going to be placed next to that node, and so on. So E will eventually be placed to the above G and to the right at the next available slot. So it will eventually be placed here, right next to C. So G has a child, so that child is H, and since there are no other children below it, H is placed directly below G. Likewise, currently there are no partners occupying that space, so F is directly placed to the right of G2. Now, what about F's parents? So F has parents A and B. Where are they placed? So the algorithm will try to place it directly above F. And if that spot is occupied, then it will look at the next available spot to the right. So the same process as when we placed E will occur for A and B. And so this entire algorithm works because we're all connected to each other. So if a node is not connected or related to you in some way, then it cannot be placed on this graph. So the process is iterative. It'll go through several cycles of trying to fit a node into the graph, and only nodes that have an established connection will be placed on the graph. So there we go. We've placed in A and B, and we know that A and B are parents of F. And those were the two available locations that those two members could fit in. Now, once we have placed each of these members into a graph, then what will happen is we'll go through and we'll identify the top left node, and we will mark that as 0, 0, and proceed through each of the nodes in our grid. So imagine like a chessboard. We go through and we mark each of these nodes based on the coordinates from that top left position. So just a normal grid place location system, but the way we generated that grid is based on the relationships between the people and the fact that we are all connected to each other in some way. So as long as that truth holds, then you will be added to this graph and everything sort of works smoothly. The moment that we can't fit a node in indicates that there is no established connection between this member and the other members in your family tree, and so they'll be left out. So that's the basic principle of this. All right, so this is now what the family tree looks like once it has been brought into the front end. So as you can see, it matches the diagram that we had. It's displaying the mugshots of the people based on the names given and based on the connections that we have set up. And it's pretty basic at the moment, but it just demonstrates that we can place these nodes into a tree and they sort of appear where we expect it to appear.